This is something new we're going to look at today. But the stuff we're going to work with is familiar to you. So we already know how to find the exact values of certain radicals. Okay. So if I said, what's the square root of 36? You would say, if I said, what's the square root of 27? You would say, whoops, cube root of 27? 3. Okay. However, there are some, or actually there are many, that we can't evaluate exactly. Like square root of 8. We can approximate them using a calculator, but we can't take their exact value. Because the square root of 8 is going to be between 2 and 3 somewhere. Okay? You can take the square root of 8, but you're going to need a calculator to do it. Okay? So I want to make a correction here. Many radicals, such as the square root of 8, cannot be evaluated to an exact rational number. Cross out and then put in an exact. They can be evaluated using a calculator, but as soon as you use a calculator, it only becomes an approximate answer. And we learned in 1.3, we learned in 1.3 that the square roots of non-perfect squares and the cube roots of non-perfect cubes are irrational numbers, meaning they can't be written as fractions. Okay? We're going to do something new with radicals. And it's not going to involve using a calculator and rounding them. We're going to get away from that now. We're going to answer in exact terms. Like if I took the square root, you don't have to write this down, but if I took the square root of 8 on my calculator, so I've got the square root of 8, and then if I punch it into my calculator, I get 2.828 if I round it. Which one of these is more exact? Why? Why the top? Yes, this one is rounded. It's not exact because it goes on forever. Doesn't repeat, doesn't end. If I just leave it at this form, it's exact. Okay? It's like, which is exact, the pi symbol or 3.14? The pi symbol. Okay? Because as soon as you go to 3.14, you're approximating. So what we're going to do is we're going to work with what's called exact values. And we did that with areas of circles and circumference of circles last year. And this is kind of like reducing fractions in a way. Like whenever you guys worked with fractions and you got to some answer, you always had to make sure it was reduced. Well, with radicals, if you're going to work with radicals and you get to the end, you got to make sure they're simplified. And we're going to talk about how to simplify them. And you need to know two things. Okay? One, how do you multiply radicals together? What's the square root of 4 times the square root of 9? 6. Why? Yeah? So the square root of 4 is 2. The square root of 9 is 3. And 2 times 3 is 6. Okay? Or you could have done it this way. When you multiply 2 square roots together, or 2 cube roots, or fourth roots, you can multiply the numbers underneath and put it under one radical. So square root of 4 times the square root of 9 is the same as the square root of 4 times 9, which is the square root of 36, which is 6. Same answer. So what does that mean? Whenever you multiply two square roots together, you can multiply them into a single square root by multiplying the numbers underneath. You can do the same thing with cube roots, fourth roots, etc. But they have to be the same roots. You can't multiply a square root by a cube root. So like if I have the square root of A times the square root of B, that is equal to the square root of whatever A times B is. If I have the cube root of A times the cube root of B, that is equal to the cube root of whatever A times B is. And you can keep going. Fourth root, fifth root. So what's the square root of 2 times the square root of 5? Don't overthink. Square root of 2 times the square root of 5. Square root of 10. And we can't take that without a calculator, so we leave it. Okay? What's the square root of 4 times the square root of 8? And we can't take that exactly, so we leave it. Actually, we're going to be able to simplify that one that we'll see in a second. What's the cube root of 7 times the cube root of 6? Cube root of 42. Okay? That's how we can multiply radicals together. That's one thing you have to know. The second you have to know is some of your basic perfect squares and perfect cubes, which we've talked about last year and we've reviewed this year. Start listing for me the positive perfect squares. What's the smallest positive perfect square? 1. Not 2. 2 is not a perfect square. 4. Not 6. 9. 16. 25. 36. 49. 64. 81. Give me one more. 100. How about the perfect cubes, the positive perfect cubes? What's the smallest one? 1 again. 1 is a perfect everything. What's the next one? 8. Excellent. 27. 64. Give me one more. And we'll stop there. 5 times 5 times 5? 125. Good. Okay. So we got to know these two things. Okay, here's how we simplify radicals. And you can't simplify all radicals. And you'll see why in a second. I can't take this exactly. I would have to use a calculator and it's no longer exact. But I can simplify it. What we want to do when we see one of these, okay, that we can't take exactly, find the highest perfect square, because it's square roots we're dealing with. That goes into 27. What's the highest perfect square that divides evenly into 27? You've got your list of perfect squares right there. 25 does not divide evenly into 27. 9. Therefore, I can break up the square root of 27 into the square root of 9 times the square root of what number? 3. Why did I do that? Because I can take this exactly. What is the square root of 9? 3. So I can simplify this to 3, and I don't need the multiplication symbol, square root 3. And we read this like 3 root 3. Like I said, it's kind of like reducing fractions. We call the original, because it's an entire square root, we call this an entire radical. We call the simplified form a mixed radical. Why mixed radical? Because it is a mixture of a non-radical and a radical. It's got a 3 times a root 3. So what we did is we simplified from an entire radical to a mixed radical. So to simplify these things, you find the highest perfect square, break it down, and simplify. Don't worry, we're going to do more examples. Okay. This one, notice we're not dealing with square roots anymore. We're dealing with cube roots. So I don't want to find the highest perfect square. I want to find the highest perfect cube that goes into 32. And what number would that be? 8. Therefore, I can break up the cube root of 32 into the cube root of 8 times the cube root of what number? 4. Because 8 times 4 is 32. Why did I do that? Because I can take the cube root of 8 exactly. What is the cube root of 8? 2. And then I don't have to write the multiplication symbol because it's implied. So it looks a little funky. But we would read that 2 cube root 4. And you've simplified it. You can't do this to every radical because, I mean, there's many radicals that a perfect square doesn't go into. Well, actually, 1 does, but 1 doesn't help us. Okay. So let's practice with a couple more. Square root of 28. So here's how I would look at it. I would go like this. I don't have to write all that stuff out. First thing I'm going to do is break it up into 2 radicals being multiplied, 2 square roots. A number under the first one has to be the highest perfect square that goes into 28. Which would be? I don't hear anybody speaking with confidence. 4. Which means the other number must be 7. Now, one step further. What do I get? 2 root 7. That's it. This one, you got to change your thinking. You're not breaking it down to square roots. You're breaking it down to cube roots, where we got to find the highest perfect cube that goes into 144. Don't be afraid to use a calculator to help you. 36 is not it goes in, but it's not a perfect cube. 12 doesn't go in, or it's not a perfect cube. 64? Are you just guessing? Somebody want to tell me whether 27 goes into it? Somebody want to prove to me that it goes into it evenly? It doesn't? Okay, so 27 doesn't go in. 64 doesn't go in. Try 8. Yes, it does. Cube root of 8 times the cube root of what? 16? Come on, you guys. Be confident. This simplifies to 2. This you can't simplify, so you leave it. 2 cube root 18. This next one, you got to be careful with. Notice when I did the first couple of examples, I said highest perfect square and highest perfect cube. There are some numbers where more than one perfect square goes into it. You have to find the highest to simplify it completely. Many of you might look at this one and say 4. And 4 is a perfect square that goes into it, but it's not the highest. There is a larger one. 8's not a perfect square. 16 times 5, which becomes 4 root 5. Okay? If you did 4 and 20, you haven't simplified it completely. So something to remember, if the number's fairly big, and if 4 goes into it, check 16, just in case. If you can do the next one, I'll let you go. Oh, my God. Oh, come on, you can do it. Yeah. Come on. We're thinking cube roots now. So we're thinking perfect cubes. Split it up. And? Well, no. 8 goes.
Yeah, right. 8 and 5.
Okay, finish it, Ava. Okay. Done. Ela, you all right?
2. Yes. Yeah.
2.
5. 5. Yes.
What are you doing? 2 cube root 5. Good job. Ayla, next one. Uh, hmm. Uh-huh. Yeah, give me a minute, she says. Anybody want to help, Ayla?
13. Yes.
13's not a perfect square.
Oh. 9.
9 doesn't go evenly into 26. Neither does 4. 16 does not go into 26. 1, but that doesn't change anything, does it? Because then it would be square root 1 times square root 26, which is 1 root 26. No.
It's not possible.
Excellent.
Yes.
You can't. So you leave it. Remember what I said? There are many that you can't take exactly and you can't simplify. So if you can't do anything to it, you just leave it. But you can do something to see. It can break down. 9, which means the other one is right, which simplifies further to 3 root 6. Now you guys are getting it. What if we were asked to go the other way? Step 1, remain calm. So like, here's the answer. What was the original question?
I got this.
You're on the right track.
6 square, wait.
6 square, what?
Wait, let me.
Okay.
Hold on. 48.
Almost.
What? Oh my goodness.
No, you didn't get the number wrong.
Oh.
You just haven't said it properly.
48 square.
No.
Square root.
Square root of 48. So we work backwards. What we need to do is we need to write 4 as a square root. How do you write 4 as a square root? Just go 4 times 4, and it's square root 16. And then you times that by square root of 3, and you guys know that you can multiply 2 square roots together into a single one. Square root 48. What would you do for B? Not cube root of 3. You said the same thing.
Wait, it's 54.
No.
Wait,
3 to the third.
Yes.
Yes.
3 times 3 times 3. Meaning it equals cube root 27 times cube root of 2, which multiplies into the single entire radical of cube root 54. Good. Try C. Should be able to do C. Yeah.
Wait, wrong. Oh,
That's a way to encourage her.
100 square root. Wait, I forget how you say it.
Emily,
Oh,
square root of 50? What? Yeah?
oh, square root of 100.
You say square root of 100?
Five.
You're going to say 5?
Go on to the oh, you want this is the final answer?
No, I want the final answer.
Oh. Square root of 50. Wait, no, wait.
Yes.
Oh,
Yes.
what the final?
Yes, I'm just messing with you.
Oh. Is it element three?
Not the final answer. Give me the final answer.
Wait, no, it's not.
But I want the final answer.
I got square root of 50.
That's your final answer?
Wait.
Don't look at her. Don't look at her.
Yes.
Yes, I am. I'm messing with your head because I want you guys to be confident. Say, no, it's the square root of 50.
It's the square root of 50.
Right, it is.
Did you get that answer?
So we do 5 times 5. We get square root of 25 times the square root of 2, which is the square root of 50, right?
Yes.
Wrong.
Yes. We're right.
Yes, you're right. Good. See?
Guys, I was doubling that.
And you guys could find mistakes in my answer keys. So don't assume that, like, if there's a mistake, if your answer doesn't match up with mine, mine could be wrong. What? Hello? You know the next question. Okay. So here's where we can use exact radicals. And one way is using Pythagoras. When you guys did Pythagoras before to find a missing side, you either got an exact answer or you pulled out your calculator and you rounded it. Now, why do you look at me like I'm the one with the problem? Like you look at me like, what? I'm sitting there eating goldfish and throwing them around the class. What? Yeah, you did throw it around.
I think I'm right.
You haven't even answered the question yet. You think you're right? By eating goldfish? Oh, so it has nothing to do with math. You just can't stop stuffing them in your mouth. You can't even stop to have a conversation. They got to just keep going. Oh, jeez. Yeah, what's your point? All right, Brea.
No, I actually don't know. Is it a squared plus b squared equals c?
Yes. So to find the missing side, a squared plus b squared equals c squared. A and b represent what?
3 and 6.
The,
The one.
give me the word. Okay, right. What do we call them? The what? The legs. So A and B represent the legs. Longest side represents the hypotenuse. So, do I know both legs?
Yes.
Yes, so I'm going to put 3 squared plus 6 squared. Doesn't matter if I put 6 squared plus 3 squared, gives me the same thing. Instead of C, though, I'm told that the third side, the hypotenuse, is X. So we've done these once before. So 3 squared is 9 plus 6 squared is 36. We add those two, we get X squared is equal to 45. Therefore, X is going to be the square root of 45. And that's when you pulled out your calculator and you rounded it. But we're not doing that anymore. We're going to go to the exact answer, which means we got to break it down. And you, final answer?
3.
Done?
Yes. Yes.
Yes. No.
No, you do this. All right. I am ready.
Yeah. You will find the units on the whiteboard, not on my face.
Oh, centimeters.
There you go. Well done. Good job.
I'm remembering.
I thought with my brain, and I did good. Okay. Oh, that's so sweet. Okay, what if I gave you this? You don't have to write this down. Here's a square. The area is 12. We won't worry about the units.
Square it and
I want to know the length of one side. Nope.
No, you square it.
Nope.
Square root it.
You got to square root it. You got to find the side, you got to square root the area. That's a simplified radical. Break it down.
4 and 3. 2 root 3.
Nice. Well done. Okay. 4, Thursday. 1.4. What, doing what?
It's not this lesson.
Oh, that's just, we've listed those. Yeah. Okay, 1.4. Does everybody have a copy of the test outline and review exercise? Okay. So, you don't? Okay. 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 Yep. Yep. Yes. So 1.4 for Thursday. Thursday, we can maybe go to the boards and do a couple questions together. And then you'll also have time to work on the review exercise and ask me questions. Okay? At the very least, when you study, okay, at the very least, you should be doing the review exercise. That's good study. If you need to do, would you just hold on to that? Oh, am I still recording? Ooh. I am. That's going to be an entertaining video.
what?